Hello dear students, welcome to chemistry class. In this class we are discussing about the statement of Born-Lande equation for the calculation of lattice energy. The statement of Born-Lande equation for the calculation of lattice energy. Okay. And in last class we have discussed about the lattice energy. Okay. And in this class we are discussing one of the equation, or we can call that one as a formula, which is given by the two scientists Born and Lande in the year of 1918. In 1918, these two scientists Born and Lande given an equation to calculate the lattice energy. Okay. And the statement of that equation is, this equation states that lattice energy can be derived from ionic lattice. The lattice energy of a particular lattice or ionic lattice are derived from that ionic lattice based on electrostatic potential of attraction and the potential energy due to the repulsion. This is the statement of Born-Lande equation. This equation states that lattice energy can be derived from ionic lattice based on electrostatic potential of attraction of the combining atoms which are forming the solid, ionic solid, and the potential energy due to the repulsion of those combining atoms. So, here I am writing the equation for that statement, and as we have discussed that the symbol for lattice energy is capital U minus Na m z plus z minus E square divided by 4 phi epsilon naught r into the bracket 1 minus 1 by n, and the unit for this one is kilojoule per mole. Okay. This is the Born-Lande equation to calculate the lattice energy. U is equal to negative Na m z plus z minus E square divided by 4 phi epsilon naught r into the bracket 1 minus 1 by n, and the unit for this one is kilojoule per mole. And according to the statement, when we open this bracket, the quantity which we are getting in negative value is the value which is given by the electrostatic force of attraction between the combining atoms, and the term or the quantity which we are getting in positive value, that is due to the potential energy due to repulsion of the combining atoms. Okay. See here, after opening this bracket, we are getting this one minus Na m z1 z plus z minus E square by 4 pi epsilon naught. This one quantity is due to the electrostatic force of attraction between the combining atoms, and minus into minus becomes plus Na m z plus z minus E square divided by 4 phi epsilon naught r n. That quantity or that term which we are getting in a positive sign is the energy or the potential energy due to the repulsion of the combining atoms. Okay. Then why we are telling the energy due to the attraction and energy due to the repulsion? See here, we can draw one graph. This is R, and here is lattice energy or the potential energy, or we can say this one as a potential energy or lattice energy. The below this one is negative value and above this one is a positive value. When the two combining atoms are brought from infinity to close each other, first they will attract means their energy goes on decreasing, and here as the R, that is the internuclear distance R goes on decreases, the energy goes on decreases. Okay. And up to the certain level, when the two atoms come closer, nearer, the potential energy suddenly goes on increasing. When two atoms are brought from infinity to close each other, there will exist an attractive force between them, and hence the total energy of that system, molecular compound, goes on decreasing as the interionic distance or interatomic distance r goes on decreases, the energy goes on decreases. But at a certain distance, at a certain close distance, when the two atoms come close each other, there will exist a repulsive force between the combining atoms. Then automatically the energy goes on increasing. At this much distance between the combining atoms, the energy goes on increasing only because of the repulsion between the combining atoms. This is the statement of Born-Lande equation to calculate the lattice energy. And here we know that, here I am explaining each term. Here U is nothing but an lattice energy, and Na is Avogadro's number. Avogadro number, what is its value? 6.023 into 10 raised to 23. Na is Avogadro number, and M is Madelung constant. M is a Madelung constant, and it completely depends on the geometry of substance, or we can write a crystal. This M is nothing but a Madelung constant, and the value of this Madelung constant completely depends on the geometry of the substance or a crystal. Okay. Then Z plus is numeric charge number, numeric charge number of cation, and Z minus is numeric charge number of anion. See here, as we have already here written negative, one cation is there, one anion is there, means take for example NaCl, Na plus is there, Cl minus is there. What is the charge on Na? Plus 1. What is the charge on Cl? Minus 1. Then on multiplying these two, we will getting negative sign. Therefore, I already written here negative sign. Now we are here, Z plus means what? The numeric charge number of cation. Numeric charge number of cation means only 1. Here we should not include the sign. Numeric charge number they are asking. Numeric charge number means 1, and the numeric charge number of anion is also 1. Okay. Then E is nothing but a charge of electron, E square. E is nothing but charge of electron, that is 1.602 into 10 raised to minus 19 coulomb, and epsilon naught is a permittivity of free space, permittivity of free space, and its value is 8.854 into 10 raised to minus 12 farad meter, and R is a distance of separation, distance of separation between positive and negative ions, distance of separation between positive and negative ions, and N is a Born exponent. This N is nothing but a Born exponent, and its value is between 5 to 12. It completely depends on the what material we are using, what type of solid we are using. It is ranging, the value of Born exponent is ranging between 5 to 12, and we know the value of phi also 3.142, phi, the value of phi is also 3.142. This is all about what? The statement of Born-Lande equation for the calculation of lattice energy. Here Na means Avogadro's number, Madelung constant, numeric charge number of cation, numeric charge number of anion, charge on electron, permittivity of free space, and the distance of separation between positive and negative ion, Born exponent, and phi value is 3.142. Okay. Then now this is only there for our syllabus, and now we can calculate the lattice energy of the NaCl crystal by using this formula. And we have discussed in last class that the experimentally determined lattice energy of the NaCl crystal is minus 770 kilojoule per mole. Then now by using this formula we can calculate and we can correlate the experimentally determined value and the calculated value of the NaCl. Then we have the formula U is equal to NaM Z plus Z minus E square divided by 4 phi epsilon naught R into 1 minus 1 by N. This is the formula. By using this we have to calculate the lattice energy of NaCl. And here they have given already given the Avogadro number Na is 6.023 into 10 raised to 23, and M value, Madelung constant value for the NaCl is 1.747 for NaCl, and Z plus is 1 for Na and Z minus is 1 for Cl, correct, and the charge of electron is 1.602 into 10 raised to minus 19 coulomb, and phi value is 3.142, correct, and epsilon naught value is 8.854 into 10 raised to minus 12 farad meter, and R, that is the inter ionic distance, is 2.81 picometer for NaCl, Na plus and Cl, and the value of N, that is the Born exponent for NaCl is 8. For NaCl the Born exponent is 8. Then now by using all these data we have to calculate this one, minus what is the value of 6.023 into 10 raised to 23 to 1.747. What is the value of Z plus 1, Z minus 1, and E square 1.602 into 10 raised to minus 19 square divided by 4, 3.142, epsilon naught value 8.854 into 10 raised to minus 12, and R value 2.81 into 10 raised to minus 12 meter. This is picometer. I am converting here into meter because here already the one term is there in an unit of meter. Okay. Then into 1 minus 1 by N, and the value of N for NaCl is 8. Then now you calculate this one. After the calculation we are getting the value of minus 755 kilojoule per mole. Okay. This is the value of lattice energy for NaCl, that to calculated value, but the experimentally determined value is minus 770 kilojoule per mole. Okay. Then by this we can say that the equation or the statement which is given by Born and Lande is holds good to calculate the lattice energy of any given crystal. Okay. Thank you.